Okay guys, now I will show you how to find the height and the initial velocity given only the time of flight and the acceleration of gravity. So what is given, we are not interested in finding g in this lab. Let's assume it's given, and the time of flight. So the ball is released from some height that is unknown, bounce off, so we don't know the first height, and then come back over here, and then back again, and then come back over here, and back again, come back over here, and back again. And the information that we have is the timestamps of the sound. Those are our only measurements. So if we hit the table at this time and then hit the tables again at this time, this is time of flight from here to here. And you see the time of flight gets smaller and smaller because the height gets smaller and smaller. So this is one-dimensional problem. This is one-dimensional free fall. And this is the kinematic equation. Once it hits the ground and then hits the ground, so the initial position is 0. Initial velocity is minus 1/2 gt squared. So in time, if this is time, no position, we are dealing with this. And we want to find this. That's the rebound height. And we want to find the initial velocity. Again, this is t, this is no x. So it doesn't make sense to talk about the angle over here. We are ignoring displacement in the x-axis in this lab. Alright, so we have y equals b naught t minus 1/2 gt squared. And we know that the maximum height happens when the velocity is 0, and that's obviously because dy dt is the velocity, and that is b naught minus gt. And you said the derivative to 0, the velocity is 0 at the top. If you like mathematics, you say the derivative is 0 at the top, at the maximum. If you like physics, you say the velocity is 0 for an instant at the top because it's no longer moving upward, it starts moving down. So the time at the top is the initial velocity divided by g. So at this time is at the top, let's call it t top, and the time of flight is this one, is how long was the ball flying. So time of flight is going to be twice that. Okay, that's the time of flight, twice that. Now another way to see it, the height over here is 0. So if you say y to 0, 1t cancel, and you get exactly the same equation for the time of flight. So why is this important? Because this is the only thing that we have. The only thing that we measure in this lab is this. Hit the table, hit the table. So from here we could calculate the initial velocity because that is unknown. That is the velocity at which the ball leaves the ground. So you have is going to be 1/2 g the time of flight. Okay, that is another equation to have in your arsenal for something that we are going to see later. Now, how to find the rebound height? How to find h? To find h, you need to evaluate y at the top, or y at the time of flight divided by 2. I'm using the second one because that is what you measure. So h is v naught time of flight divided by 2 minus 1/2 g time of flight divided by 2 squared. Now we substitute the initial velocity. The initial velocity is 1/2 g time of flight over 2 minus 1/2 g time of flight over 2 squared. So a half and a half is a fourth time of flight squared. A half, and this is 2 squared. 2 squared is fourth times 2 is eighth, 1/8 g time of flight squared. So the height given the time of flight is 1/8 g time of flight squared. And this is the equation. Oh, I didn't move the paper off. So remember, I used the fact that the initial velocity is 1/2 g time of flight. Substituted in the equation for h, remember h is v naught t minus 1/2 g t squared. If you substitute in this equation the time of flight divided by 2, you get this equation. This is the equation that you are going to use to calculate the height given the time of flight. And what is happening is this is the table, and you have the height that you drop it from, and then you have another one, and then you have another one, 1, 2, 3, another one, and get the height, the rebound height gets smaller and smaller. So the objective of the lab is to see by how much, what percentage the height diminished after rebound, and to see if that percentage is constant. Again, the equations to use in sheet is this one, and there is a bonus section that you have to use the velocity as well. So given the time of flight, so the ball hit the table and hit the table and hit the table and hit the table. From these times of flight, that is this difference over here, we are able to know how high the ball is.